Hello, boys and... Oh, hold on. I gotta get the microphone. Hello, boys and girls. How are you? We are on Chapter 5, Lesson 3. Now, the name of this lesson is Common Factors. Okay? Factors, you know, those are the builders in the factory, right? 3 times 2 equals 6. 3 and 2 are factors of 6. Okay? Now, in this context, the word common means numbers that have things in common. When you think about people that have things in common, means that they have things that they have the same about them. Like pizza is my favorite food. Is pizza your favorite food? Yes? Then we have that in common. It's the same about us. So we are looking for numbers that have factors in common. Okay, factors that are the same for both. So let's jump in here with number 2. Simon is making wreaths to sell. He has 60 bows, 36 silk roses, and 48 silk carnations. Okay, so do you know what a wreath is? You know, it's like a circle and you hang it on your door and you could put bows or berries or whatever you want on them. Simon is putting bows, roses, and carnations on his wreaths. He wants to put the same number of items on each wreath, and all the items on a wreath will be the same type. Okay, so he wants to make a wreath that has just bows, or just silk roses, or just silk carnations. And we want to know how many items can Simon put on each wreath. So we have to think of ways to divide 60, 36, and 48 the same way. Or we need to think of factors that they have in common. Okay? 60, 36, and 48. Those are some whoppers right there. So I know that in the lesson they would 60, 36, 48, and they listed the factors down like that in a list. That's fine if you want to do that, but just because of the space that I have on here, I'm going to list them across. 60, 36, and 48. Dot, 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 dot. Okay. 60 has a lot of factors, boys and girls. That's going to be a whopper. So 1 is, of course, a factor of 60. It's a factor of 36, and it's a factor of 48. So what that means in this problem is that Simon could make wreaths, and each wreath would have 1 bow, or 1 silk rose, or 1 silk carnation, because all the items on the wreath will be the same type. So each wreath could have 1 thing on it, of course. Okay? So as I'm thinking divisibility rules here to start. These are all 3 even numbers, right? 0, 6, 8 in the ones place. A number is even when it has 0, 2, 4, 6, 8 in the ones place. So I know that 2 is going to be another possibility. So Simon can put 2 bows, or 2 silk roses on a wreath, or 2 silk carnations on a wreath. Now before I go any further, let's think of the factor partners for each of these. Okay, so the factor partner for 1 is 60. Now what do I mean by that? I mean that 1 times 60 is 60. And I'm putting it all the way down there at the end so we can kind of fill in here in the middle. The partner of 1 for that's 36 and 1 for that's 48. Okay? Factor partners for 2. That means 2 times what? Or factor pair, I think they called it. 2 times what is 60? Okay, so what's half of 60? Right? 2 times what is 60? Well, what's half of 60? What's half of 6? 3. What's half of 60? 30. Okay? 2 times what is 36? So you can do the same thing. What's half of 36? Or if you want to, you can do a little division problem. Okay? It's completely up to you how you find these factor pairs. Okay, 1, 2 minus 18. 2 times 18 is 36. And then let's do the factor pair for 2 and 48. We used 48 in the last lesson. And I remember we thought about what's half of 40, 20. What's half of 8, 4. So half of 48 is 20 plus 4, or 24. All right? Now we're going to think about our friend 3. I'm using my divisibility rules. Okay? Remember, add the digits, and if you can divide that number by 3, you can divide the whole number by 3. So of course 6 plus 0 is 6. Is 6 divisible by 3? Yes. 6 divided by 3 is 2. Then 60 is divisible by 3. I'm going to add 3. I'm going to check for 36 now. 3 plus 6 equals, oh, I almost wrote 36. 3 plus 6 equals 9. And what do you say to yourself? Is 9 divisible by 3? It is. So is 36 divisible by 3? Yes. Now let's do the same for 48. 4 plus 8 equals 8, 9, 10, 11, 12. 12. So you ask yourself, is 12 divisible by 3? Let me see. 3 times 4 is 12. Yeah. 3, 6, 9, 12. Yup. Then 48 is divisible by 3. Okay? All right, now let's get the factor pairs going here. 3 times what is 60? Well, 3 times 2 is 6, so 3 times 20 is 60, right? What's the factor pair for 3 and 36? Well, like I said, if it doesn't pop right into your head, you can do some division. You know what I'm going to do for 36? I'm going to break it apart into 30 divided by 3 plus 6 divided by 3. Don't forget about this distributive property. So 30 divided by 3 is 10. 6 divided by 3 is 2. So 10 plus 2 is 12. What is the factor partner for 3? 12. 3 times 12 is 36. We just divided 36 by 3 and got 12. So 3 times 12 is 36. Factor partner for 48. I'm going to do the same thing for 48, except I'm going to break apart 48, not into 40 plus 8. That won't help me divide by 3 at all. How about 30 and 30, 40, and 18? Yep, those are 2 beautiful numbers. You can divide by 3. 30 divided by 3 is 10. 18 divided by 3 is 6. So 3 times what is 48? 16. Okay? So now we are on 4. So let's think about 60 divided by 4. I'm going to use the distributive property again. I'm going to take 40 out. 40 divided by 4, because we're dividing by 4, of course I'm going to use 40. Love my tens. So what's the rest of 60? 40, 50, 60, 20 divided by 4. Okay, that's 10 plus 20 divided by 4 is 5. Okay, is 60 divisible by 4? It is. 4 times 15. There's another factor pair. So is 36 divisible by 4? Now guys, 36 divided by 4. That's basic fact land, right? Once you get to these numbers like 36 and numbers that aren't too gigantic, don't be like, well, I don't know. You do know. You know that 4 times 9 is 36, don't you? Yes, of course you do, because you're a little genius. All right, now how about 48? Is 4 a factor of 48? I'm going to break that one apart too. Into 40 divided by 4. And what's left? 8. 8 divided by 4. Oh, now I can just look at those, and yes, 4 is, oh, I want to do that in red. 4 is definitely a factor of 48. And what's the factor pair for 4? Well, let's go back over here. 40 divided by 4 is 10, plus 8 divided by 4 is 2. So the factor pair is 12. 4 times 12 is 48. Oh my goodness, I'm running out of space here, aren't I? Okay, back up here to 5. 5 is definitely a factor of 60 because it has a 0 or a 5 in the ones place. Whoop. So I know that 5 times 10 is 50. So 5 times 11 is 55. So 5 times 12 must be 60, right? So look, 5 is not a factor of 36, and it's not a factor of 48, because look at that ones place, 6 and 4, right? Now look at my list for 60. I've completely run out of space. Well, let's do 6 now. I'm going to have it burst out of the list right here. Is 6 a factor of 60? Is 6 a factor of 60? Yes, you guys know that one. And what's the factor pair? What times 6 is 60? 10. So 6 and 10. Okay? Now, for 36, we're on 6 now. Is 6 a factor of 36? Again, basic fact land. Yeah, 6 is a factor of 36, because 6 times 6 is 36. But I'm not going to write 6 2 times on my list. We just know 6 is its own factor buddy. Okay? All right. Is 6 a factor of 48? Let me think about that one. Divisibility rules. If 2 and 3 are factors, then 6 is a factor. Okay? Now, you probably knew that because this is basic fact zone again. 6 times 8 is 48. Okay? Now, we are, gosh, we've done a lot, you guys. We are at 8. All right, let's think about 8. Like I said, let's give 8 a try here. Is 8 a factor of 60? So what can we do here with 60? I think asking basic facts. 8 times 7 is 56. 8 times 8 is 64. No. We went right past 60, didn't we? All right, so let's go to 36 now. Is 8 a factor of 36? Let's see. Basic facts here. 8 times, let me see. 8 times 4 is 32. 8 times 5 is 40. Nope. Went right past 36 again. Now, we're looking at 8 with 48, and look, it's kind of written oddly, but 8 is a factor of 48 because we already have that one listed, right? So as you go on, now look, we are already up to 10 here that we've thought about factor partners for. We're already at 9 there, so we can stop, okay? Because all we're going to be doing is reversing everything we've already done. We have 15, so you can stop now once you are starting to find factors that you're thinking about, okay? So let's look at this list of insanity we have here, because we need to find out how many items of the same type he can put on a wreath. He can put 1 item on each wreath. That's the same. 2 or 3 or 4. And then look, don't forget our 6 up there. Or 6. Now let me see. Oh, we don't have 5 or 10 anywhere else. How about 12? 12, 12. Oh, there's 12. 12, 12. That 2 looks like a Z right there, doesn't it? Let me make it look more 2-y. 12. Okay, so 12 is 1. There's 15. No, to 20. No 20. No 20. 30. Nope. 60. Nope. So then look for 18 up here. No. 16. Nope. I think we found them all, boys and girls. So the factors they have in common are circled, and that's how many items Simon can put on a wreath. For example, if he wants to make a wreath, now that's the 36 of silk roses, he can put 12 silk roses on one wreath, 12 silk carnations on a wreath, or 12 bows on a wreath. Okay, all of those numbers are factors. I mean, 12 is a factor of all of those numbers. 12 is a factor of 60, of 36, and of 48. So Simon can put 1, 2, 3, 4, 6, 12 items on each wreath if he has 60, 36, and 48 items. Okay? Now guys, it takes a long time, and you have to think of strategies, right? Like we did break apart. Go ahead and do break apart. We did a little long division. Go ahead and do a little long division. Just don't give up, okay? Keep on going, even when, look at all these factors for 60 that we have. Keep on going. Persevere. Okay? Great job. Let's keep going. All right, here we go. Number 5. A debate competition has participants from 3 different schools. Okay, now a debate competition is kind of like an arguing competition. It's who can argue their point the best with factual information, not just with nonsense. So a debate is like a fancy argument, sort of. So they're having a debate competition, and they have 3 schools coming. 15 from James Elementary, 18 from George Washington School, and 12 from the MLK Junior Academy. All teams must have the same number of students. Each team can have only 1 student from the same school. How many students can be on each team? So you have to think 15, 18, and 12. How can we separate the number of students onto teams that are the same size, and each team can have only students from the same school? So how can we divide 15, 18, and 12 into equal parts the same way? Okay, that's common factors. Okay, they're looking for common factors, a way that they can divide those students so that all the teams are the same size and that all the students are from the same team. So let's see, there's 15, 18, and 12. We're thinking about factors that they have in common. So of course, 1, 1, 1. Don't ever forget that one. And then don't forget the partner for 1 is the number itself. 1 times 15, 1 times 18, 1 times 12. Okay, so far, each team can have 1 student on it, right? Not really much of a team, but that's a possibility. All right, so let's see about 2. Dun, dun, dun. Is 15 divisible by 2? Absolutely not, because that's an odd number, right? 18 and 2 are divisible by 2, so let's give them their 2. 2 times what is 18? 2 times 9. 2 times what is 12? 2 times 6. Okay, so now let's go with 3. Oh, these numbers are so much more pleasant than that last problem, right? This is basic fact land here. Thank goodness. 3 times 5, hooray, is 15. 3 times what is 18? You know that basic fact. And of course, you know that 3 times 4 is 12. Okay? So now we're on 4. 4 is not a factor of 15, right? 4, 4, 6, 9, 12, 16, 20. Nope. And 4, oh, look, 4 is a factor of 12. All right, now we go to 5. Oh, we've already done 5 there. Okay? And we know no and no to 5. So guys, remember I said before, when you start seeing the numbers over again that you've already thought about, you're probably done finding all the factors. Okay? So let's see the factors that they have in common. Well, we already said 1. So each debate team can have 1 person on it. It's not a very good team. 2, nope. 3, oh. Each team can have 3 on it because you can make teams of 3 from every school. Now look at all these numbers we have left. 5, 15, 6, 9, 18. Well, these 2 have 6 in common, but not up here. So I think that's it. I think we found them all. So let me see. Each team can have, how many students can be on each team? 1, boring, or 3, more exciting, students. Okay? Oh, that one was a lot better than the one before with about 1,000 numbers. All right, here we go. Now we are on the next page looking at the lesson check. All right, so turn your paper over. And this one says, what are all the common factors of 24, 64, and 88? Woo! We're going to attack this in a little different way, okay, guys? Because listing all the common factors of those three numbers, our heads would burst off, I think. Okay, guys, you know what I'm noticing when I look at this? I think the book has a little error because 24, 64, and 88, what do you see in the ones place? Those are all even numbers. And what's missing from every single one of those choices? What's our even number factor 2? So they are not listing all the common factors. They're leaving out 2. If you point that out to your teacher tomorrow, she'll be so impressed. You're right, Johnny. The book did make a mistake. Because 2 is definitely a common factor of 24, 64, and 88. So what I'm going to do now, though, is I'm going to see if there's anything just screaming out at me, I am incorrect. And one of them definitely is. It's D. Okay? Because a factor is a building number, right? So to build 24, how can I have 44 times another whole number and get 24? You see what I'm saying? 44 times something is 24? What? What? No, 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 no. D, you're trying to trick us and we're not falling for it. Okay, so let's see if there are any others that are like, you're crazy. Now, when I look at A and I see 1 and 4, that's only 2 factors. I don't know if that's correct because it seems like these would have more than just 2. Do you agree with me? Because when I think about 8, okay, I know 8 times 11 is 88. I know 8 times 8 is 64. Is 8 a factor of 24? 8, 16, 20. Oh, it sure is. So A, goodbye, because there are more common factors. And don't forget 2 that we talked about over here that they left out. So now I'm just choosing between B and C. I know that 1 and 4 are factors. What about 12 though? And you know what? The only reason I'm saying 1 and 4 are factors, 1 of course is a factor of every whole number, and 4 is in every single choice. Okay? You can use the multiple choice to help you. So it's either B or C, but I don't know if 12 is a factor of 24, 64, and 88. So I'm going to have to think about my 12sies. I know that 12 times 2 is 24. Okay? Think about 12 and 64. Let's do 12 times 5. 60. 5 times 1 is 5 plus 6. 5 times 2. Oh my gosh. 5 times 2 is 10. I mean, episode here. 5 times 1 is 5, plus 1 is 6. So 5 times 12 is 60. That doesn't feel like, let's try it. 12 times 6. 6 times 2 is 12. 6 times 1 is 6, plus 1 is, oh no. We went right past 64, didn't we? So 12 is not a factor of 64. It is of 24, and I don't know if it's a factor of 88, but it doesn't matter because it's not a factor of 64. So our friend B is the only one left. So guys, we used the multiple choice to help us. Okay, and there is nothing wrong with that. It's a great strategy. All right, guys, now let's do a little spiral review back to the world of Chapter 3, Lesson 4. It says, Dan puts $11 of his allowance in his savings account every week. How much money will he have after 15 weeks? So let me see here. $11 every week for 15 weeks. So that's $11 one week, $11 the next week, $11, $11, $11. Which operation do we use when we have an equal amount over and over and over and over and over again? Multiplication. We have 15 weeks, 11 each of those weeks, 15 sets of $11. So it's a good multiplication review we're having. 1 times 5 is 5. Oh, this is lovely. 1 times 1 is 1. Placeholder. Goodbye, ones place. Thank you for helping us. Moving over to the tens. Tens times the ones. 1 times 5 is 5. 1 times 1 is 1. Oh, wow. What a nice multiplication problem. Add the partial products. So Dan, at the end of 15 weeks, will have $165. That's pretty good, Dan, isn't it? Yeah, so saving a little bit each week is pretty good. All right, guys, really, really quite a homework, but you guys, again, like I said, persevere on those factors. You can do it, okay? You have lots of awesome strategies. Good luck.